You ever wonder just how cold things can get? Like, is there a limit? A universal rock bottom can't go any lower temperature. Well, there is. And believe me, it holds some of the most bizarre and mind-bending secrets in all of physics. Today, let's dive into the enigma of absolute zero. So, what is this absolute final limit? It's not just some random number, it's a fundamental law of nature. It's a point that the universe simply says, nope, you can't go past here. And there it is, minus 273.15 degrees Celsius, or for scientists, a much cleaner 0 Kelvin. That's it, the end of the line, colder than the deepest, darkest vacuum of interstellar space.
Yeah, this isn't just your average winter cold snap. We're talking about a true boundary of reality itself. It's got a name, of course, absolute zero, the theoretical floor of our universe's temperature scale. Now, to understand why this number is so incredibly profound, we first need to ask a more basic question. And that question is, what even is temperature really? The answer is the first big clue in solving this whole mystery. You know, the concept is surprisingly simple. Temperature is really just a measure of motion, but on an atomic scale. When something's hot, its atoms are vibrating and zipping around like a chaotic mosh pit at a concert. But when it's cold, those same atoms are just moving a lot slower, kind of like the crowd heading for the exits after the show. So here's the key. If you could slow those atoms down, and then slower, and even slower, you'd eventually reach a point of perfect stillness. No vibration, no movement, nothing. That theoretical point of absolute quiet, well, that's absolute zero. But here's the twist. It's like the ultimate cosmic tease. We can get incredibly, mind-bogglingly close to absolute zero, but we can never, ever actually get there. Just look at this. Since the 1950s, scientists have been in this race to the bottom. We've gone from 1 degree above zero to millionths of a degree to now, get this, billionths of a degree away. We're hovering an atom's breadth from the finish line, but that last tiny step is basically impossible. And why is it impossible? Well, it boils down to a fundamental rule of the universe, the third law of thermodynamics. The colder something gets, the harder it is to remove the next tiny bit of heat. Think of it like trying to wring the very last drop of water from a sponge. That final, impossible squeeze to get the last molecule of energy out, well, it would literally require an infinite amount of work. It's a finish line that just keeps moving away as you get closer. But this is where the story gets really wild. Because we can't actually reach the destination, the most fascinating discoveries happen when we get ridiculously close. The neighborhood around absolute zero is way stranger than the destination itself. As we approach this ultimate cold, all that thermal jiggling and noise just fades away. The rules of our everyday classical physics, they start to crumble, and we slide right into the bizarre and wonderful world of quantum mechanics. And in this quantum realm, things get weirdly wonderful. With all that thermal chaos gone, atoms stop acting like tiny little billiard balls and start showing their true wave-like nature. We see incredible things like superfluidity, where liquid helium flows without any friction at all, even defying gravity to climb right up the walls of its container. Then there's superconductivity, where electricity can flow forever with zero resistance, meaning zero energy loss. And maybe the strangest of all, Bose-Einstein condensates, a whole new state of matter where thousands of individual atoms just merge together, losing their own identities to behave as one single giant superatom. It's incredible. Okay, so this might all sound like abstract science stuck in a lab somewhere, but this strange quantum playground has actually had a massive, massive impact on our world. In fact, this whole chase for absolute zero is directly responsible for some of our most advanced tech. The discovery of superconductivity way back in 1911, that paved the way for the super powerful magnets that make MRI scanners in hospitals work. And today, being able to cool things down to near zero temperatures is absolutely essential for building the next generation of quantum computers. So the real takeaway here is that this seemingly impossible goal, this quest for the ultimate cold, isn't just some scientific curiosity. It's a key that is actively unlocking the technologies of the future. Which, leaves us with a final, tantalizing thought. The quest for the coldest thing in the universe revealed a whole new set of physical laws. So you have to wonder, What other secrets are still out there, just waiting for us at the extreme boundaries of our universe?